All right, good morning, everybody. How y'all doing this morning? I hope everybody had a good time last night, at least a good time, as good a time as I did. My name is Richard McKnight. I'm a consultant with Alfresco in the Americas, and Brian Long's also a consultant. We're going to be talking about content replication and disaster recovery and business continuity today. We're going to talk about the problem space first. Then we're going to talk about the target clients and use cases that have surfaced for this particular feature. We're going to give an overview of the functionality, and then we're going to do a deep dive into the implementation and have a short demo. And at the end of the presentation, we hope that you'll understand what we've implemented, understand the problem space we've looked at, and be able to make some informed decisions on whether or not this would be useful for you. We've had a number of clients that have come to us about moving data around between different data centers across the globe, collaborating, and also being able to accomplish business continuity and disaster recovery. These problems typically aren't the same requirement in a lot of cases. I mean, they're different requirements. I mean, disaster recovery and business continuity is one set of requirements, and global collaboration is another set of requirements. But typically, they come to us in the same engagements, and when they ask for them together. And we've looked at the problem space. In a lot of cases, there are some solutions that can solve both. If we look at the two problems in general, when you talk about business continuity and disaster recovery, you're really ensuring that you can continue operations after some kind of an event, such as the loss of a data center. Typically, you want to be able to resume operations as quickly as possible and with as little data loss as possible. When you talk about global replication, it's a different use case. Typically, you have content that needs to be made available in different regions of the world. And we have a lot of large corporations now that are global in their reach. Excuse me. And so a lot of times, content either needs to be available, produced in one region and viewed all over the globe, or there might be cases where where collaboration has to occur between different regions. Another factor that comes up quite often is where the data gets replicated. So a lot of times we have global organizations that have content that needs to be replicated, but they want to be selective about where that content gets replicated. There's some organizations that might have European locations, and perhaps they don't want to replicate content to maybe jurisdictions where the government might feel like they can look at anything they want to look at. If we look at global replication and its challenges, you've got to make trade-offs, because when you talk about replication in general or distributed systems, one of the problems you have to deal with is the fact that so you can start up and people can use the repository exactly as they had been using the main system, and because of this, we don't have to make any changes to the application. So any solution that you build is unchanged. When we look at application level replication, it is managed within the repository services, so you do have some considerations when you write your applications. The nice thing is that it can be tuned to prioritize content that's critical. You can also selectively replicate, so based on your business requirements, and this could support cross-regional collaboration. When you use the infrastructure level replication, basically your disaster recovery site is read-only, don't touch, probably not even read-only, it's probably offline, you don't even want to touch it, because as that replication is occurring, because you don't have control over the sequence of replication, at any given time it's in an inconsistent state. So I'd like to talk now briefly about what we've actually implemented. So the functional requirements we had, if you break down all of the things that we looked at with our use cases, a set of federated repositories, the ability to create distributed objects. So I can create an object, and that object can be replicated over a set of selective repositories that are in that federation. The other thing we need to be able to know when we look at any object is the state of its replication. So let's say I create an object, and I have a federated set of servers, maybe New York, Dallas, and London. And so I could create the object in New York, and maybe we have fast lane replication to Dallas. So I look at it, I can say, okay, look, I have the content there. It's been fully replicated to Dallas, and maybe to London, we just have a stub or some of the metadata saying that, expect this content to be pushed over to here. And then the other thing we talk about is repository-specific access control. So in some cases, you really want the content to be owned by a repository and pushed out read-only to the other repositories. In other cases, you might want to have the content, that distributed object, be read-write in multiple regions. And so these were some of the requirements that came up in terms of the functionality. Some of the non-functional requirements that we support are efficient replication, being able to do that replication in the most efficient way possible, the ability to control the progress of the replication. So that goes back to saying, how aggressively do we replicate? How do we use our bandwidth? How do we balance between, traffic that's going, conducting business and traffic that's doing the replication? We also need to be resilient in the face of outages. So if something does go down and then a repository comes back up, we need to make sure that we can come back into a very consistent state once things are back and up and ready. Cluster aware. So we have this kind of global federation of repositories, but when you're replicating to another repository, we have to be able to handle the fact that I might be replicating to a cluster. So do you replicate to a VIP, or do you have a list of the addresses of the cluster and kind of have a hunt group? But you have to make sure that if you are replicating to a cluster, it doesn't look like two separate repositories and you replicate to one node in the cluster and then another node in the cluster. And then the ability to add and delete new repositories in the federation. So how do I manage that federation? What happens when the membership of that federation changes, and being able to manage that? All right? Now I'd like to turn it over to Brian, and he's going to talk about our implementation.
Can everyone hear me? I have my low voice on this morning. So I'm going to talk about the implementation that we put in place. It's currently still a work in progress, but trying to solve all these different requirements. We tried to create a solution. So one of the things I want to start out with is just looking at some diagrams so you can kind of visually see what we're trying to talk about here. But in this diagram, we're trying to achieve business continuity. So we have two different repositories over an intranet. Really, it's kind of a distance, but not too far of a distance. You want to make sure that when this one goes down for some reason, any reason, power outage even, that your users can still hit repository B. And you have to consider the recovery time objective and recovery point objective on that. But to be able to quickly switch over, very simple model. And here we're talking about just on the repository side is where we're going to try and achieve that replication. When you add HA to it, which everyone familiar with Alfresco knows, you're just really creating another repository application on the application layer, still talking to the same backend. So infrastructure, it really doesn't care if you try to do infrastructure replication, but application level, we now just complicated it a little more. And to really go complex, and this is one of the use cases we were dealing with, is we have 3 different repositories now, 2 in the same area that primarily serve as a business continuity kind of requirements to, if this repository goes down, you can switch over to the other side of New York City and hope that that one's up as well. If both are down, then you can go to your disaster recovery system that's not in use, but only in use for this specific situation. And that could be over a wide area network, just who knows how far away. And so you have to deal with latency issues. There's different issues you'd need to deal with trying to replicate to this versus replicating between these repositories. So with this solution, we wanted to create something that's very flexible, very configurable, to try and apply it to as many use cases as we possibly could. So the design we kind of came up with is having this segmented multi-stage replication. I don't know if this diagram makes a whole lot of sense, but if you have a document coming in, you could synchronously replicate a stub, which is just the type, maybe mandatory properties, mandatory aspects, just enough to allow the other system to know something exists. You could asynchronously, immediately after transaction, replicate more metadata, maybe the rest of the properties. Maybe you wanted to do it separately because you have a whole lot of properties. There's customers that have a lot of records inside the properties. So you could also batch replicate anything that had failed over here, because maybe the system was down, and so you couldn't replicate synchronously, but it will store it back there and say, okay, I'll just do this later when it becomes available. You could also replicate other segments as batch, maybe even the stub. Maybe you don't want to do any of this synchronous, asynchronous. All that's configurable. You could also pull, and this one's really useful for content. I don't know any other thing that it would be useful for, but if you have the stub on one system, you know something exists, someone finds it on that other system, and then they want the content. If it doesn't have it yet, it can call back to the original repository, pull the content down on demand. And then you have your full document eventually. And that's eventually consistent replication. We have a whole lot of different node segments that we break out. Instead of just considering it one document, it's really stub, properties, associations, access controls. And we could even break it down to just a single property. When one property changed, we just need to replicate that one property. And also events, like deleting things, moving nodes, which is an incredibly difficult thing to try and scheme around. That's a technical thing now. Each of these can be scheduled in one of these 5 ways. Obviously, in transaction, after transaction, on some kind of schedule, maybe overnight you want to replicate your content because you don't want to put too much of a burden on your network during work hours. On demand, if you know that system doesn't use most of the content, but there's those few cases where it needs it, it can pull it down. And also never. If you one of those events on the previous slide was invalidate content. Maybe you don't care. Whenever something's changed, it has a signal for invalidating it, and then it puts it on the list as something to replicate as well. So you may want to send a signal like, this content's bad, it's already out of date, before you even send the content, because maybe that's overnight. So you can choose to not replicate the invalidation signals. We define something as being distributable by classifying a folder as a root of distribution, distributed root. And anything that goes under that gets replicated to another repository in that replication cluster that has the same name for a distributed root. So you'd classify it with an ID, and it would know where to replicate it, because you need to find the folder on the other system where this is supposed to be filed. So we also currently ignore, and this is configurable, we ignore renditions and thumbnails, because in these use cases we've dealt with right now, these can be regenerated on the other side, so why replicate it and add more work to what you're trying to do? All of this is achieved using a journalized, using a journal of all this stuff that's happening in the repository. In this example, we're going to call this repository A. As nodes are being added, we could say the 1 is node 1, 2 is node 2. And this is stub metadata content, stub metadata. And then metadata for node 1, and then delete node 2. It's kind of abbreviated. Repository A is up to this point, and it knows repository B is way back here. He hasn't gotten any of this information. Repository C might be here. And so in this journal, it stores one journal entry and just has pointers from each repository. So you could support, I mean, it scales very well with large numbers of repositories because it's just pointers. It's not creating a whole queue for every single repository. And then it would just be able to replay this journal to the other side when it replicates. And this is a really ugly diagram, but it tries to get across the whole transport layer on this system. For each node segment, we have the option to compress individual segments, and that's very useful for certain MIME types. You might want to compress the content. So a text-based PDF, you want to compress it. But if you are doing a whole lot of images that are scanned, they're not very compressible, you would turn that off because it's just adding extra work. We stream it, like this is how many bytes to expect. Here's the binary data, bytes, binary, bytes. Just streams it right across the channel. And there's optimizations we could still do in the future, but we also have compression, encryption layers beyond that where you can just apply it across everything. So, and we can layer anything we want in between for more optimizations. The biggest thing to consider with a model like this, with eventual consistency and having an active-active system, is conflict resolution. And the system right now, we could implement a different one depending on your requirements. And in this case, we've already implemented a simple one, which just picks the one that was changed the most recently. So it could actually wipe out someone else's change. I can't think of what I was thinking of, but yeah. I think we're already done there, but I wanted to show a demo, and considering we have time, so. This is a very rudimentary demo.
So while you're setting up, Richard,
Yep.
can I ask a question?
Sure.
Okay.
So when can we get this? How do we get this? Where is it?
That's more than one question.
No, it's one question. I just phrased it several ways.
Depending on the use case. So we have some core pieces that we've implemented. We've tried to do it in a way that we don't have to reinvent the wheel for each customer. So we have some core pieces that we've built on. Some of the features, the placeholders, like for instance, he talked about conflict resolution, or we put a simple one in there. If you needed a different one, we'd have to build that in. It would be a consulting engagement, essentially, because we don't have this as a package that we can just put in your hand, essentially.
Yeah, I mean, it's still, I mean, it's evolving with time. We don't know where this is going. It's something very fresh, I guess. If this VMware instance is going to perform here. Okay. So what I have set up here is just within share, I've defined the shared files folder as a root of distribution, and I did it on another site or another repository as well. You could have different folders that replicate to each other, different named folders, but if they have the same root ID, they'll replicate to each other. In here, I'll just create a folder as a simple example. So this is defined. I've just quickly switched over to the other repository, and it already has the test over there. In this use case, everything is replicated synchronously, everything but content. And so for folders, it's just replicated synchronously, straight over, and available immediately. You take the performance hit on the creation, but depending on the customer, they may want that or not want that. And so the configurability of changing that is quite nice. I can also try and, there's a Windows, okay. This is for my encryption talk, but here I just upload an image, and it goes in. Part of it was replicated in transaction, and I actually have the replication set to 15 seconds for the content, so it probably already replicated it, but you would see 0 kilobytes there when it's not, and we would be able to customize share with markers on there to say, oh, the content's not here yet, or maybe it will pull on demand and it'll inform you so that you're aware. But those are future capabilities depending on who wants those requirements and when we can implement it. So, and then also on this, I'm on the second system. I can create anything over here. Well, let's just delete the document that was just uploaded. And it's already deleted on the other side. So it's just, that's one of those things that's also synchronous. They're configured in this, at this time as synchronous. All could be batch, all could be synchronous. It's up to you. So that concludes the session. So any questions? I'm sure there's a few. Yeah.
How do you store the journal nodes? Are they Alfresco nodes?
Right now, it's Alfresco nodes. This whole thing uses public API and nothing else, and it uses Alfresco, all contained, no external requirements, just an amp to install and a configuration. There's 2 configuration files. One's a Hazelcast, which just does membership management, essentially, so it's fine for large or WANs. And the other is the configuration of the module, like Alfresco global properties. You would enable the subsystem because it's a subsystem, and schedule cron schedules and whatnot. So.
So the bidirectional, you just demoed bidirectional changing to the journal. So is there one journal?
No, one for each.
Journal for each
Yep.
side?
Right now, there's one for each side. I mean, there's things we want to do to change that. We want to use like ActiveMQ, which is now being included in Alfresco. And if that gets exposed as an official API through Alfresco, that would be great. We would just be able to switch to that. Also, it's pushing this content from one repository to others. And so if that repository is down, that content won't get pushed, even if it's on some other system. And we want to change that so when a repository comes on, they ask, or through Hazelcast, they're just like, how up to date are all of you? Oh, I need more from you. Who can give me that data? And then be able to stream it back and possibly collect statistics on who has the lowest latency, who has the most bandwidth, and then maybe choose that repository to get that data, or get it from multiple ones at the same time. So.
I got a question way back there.
Yeah.
My question was exactly the same. I mean, it's a shared state, the journals, but then now you have replicas with that one. But you also need to keep the state of this one to another journal.
Yeah, correct. And originally, I even had it where when it replicated to another one, it stored kind of a copy of the other one's journal. It was kind of manually doing that shared journal, but I'd like to have another framework that does that for me. So that would be hard to maintain. So, yeah, over here. You.
You talk about conflict resolution.
Yeah.
How do you intend to deal with, for example, if you have two local repositories pushing the same file with the same name,
Yeah.
you get a duplicate name
Yeah.
exception. How
And
do you intend to
within that, it's all Spring services. There's a service called Merge Service, and within that implementation, it does that store, and it will throw that exception that in the default implementation. It'll catch that, and then it will look at the two and see which one's newer and choose that one. And if they happen to be the same date, then there's another piece of logic to make sure that both repositories, when that same content gets replicated to the other one, they both need to choose the same one. Otherwise, it gets hairy. So.
You know, the thing is that that's one implementation. I mean, we could have a number of implementations. I can even envision, you know, one where you pick one, but then you have the other one in a parking lot or in a penalty box somewhere where you can go back and look at
Quarantine.
it.
It'd just be a rendition, and you have a little flag in share that says
That's another way to
there's
do
a
it.
merge conflict, and you click on an action that says show me the merge conflict. And
Yeah.
Optimally, I want to be able to use the versions and insert a version in between the two, but that's not available in a public API. So.
How would you deal with deletion as well? So I'm a user working inside of test folder that's at later timestamp. Someone else has deleted the test folder. So
Yeah.
that seems to be tricky.
On the other side, it's going to get a bunch of data saying update this, and that side will say I don't know what the heck you're talking about, and it knows enough that it's not a normal failure. It's this must have been deleted failure, and so it actually acknowledges and says everything's fine. This should have been deleted. And eventually, that folder delete goes across all the systems, and they'll all reflect each other. I mean, there are some weird conditions that we still have to account for, like especially moving something into a distributed route or out of it, or from one to another. It's really just on another repository that could be a remove and a create, because maybe one repository has two distributed nodes, but another one only has one of them. So from the other's perspective, you're just deleting something. So, yeah.
So we're not transferring renditions, but I guess we could.
You could, yes.
If I did transfer a rendition, how are the associations also taken across? Are they taken across?
Yeah, I mean, it follows all the child associations and whatever types, and it just replicates it directly. I haven't tested sites because sites themselves are kind of special case, but
So if you took a node across with associations and the target wasn't there, you wouldn't apply it. But if later on you put the target of that association across, it would also bring it back both ways.
yes.
Does this cover discussion forums, wikis, etc.?
Oh, nothing's out there yet. We plan to have that. And we have to do. We're going to do a white paper with this demonstration as well, and start creating that documentation. So.
I think the question
Oh.
was, can you actually synchronize
Oh, okay.
like, in a share-sided discussion a wiki?
I'm not sure. I haven't looked at the wiki stuff, but if it's nodes within Alfresco, it should work.
Yeah. So discussions and things like that, like on a document, are generally children.
Yeah.
Like through a site where you've got the discussion forums under
Yep.
a site,
Yeah.
wikis under a site, which show up in the repository browser, but you don't sort of see the nodes and things.
The one challenge to that might be the fact that you would then force the sites folder to be a replicated folder. The one thing, because sites is one monolithic folder, what you have is a situation where you couldn't selectively replicate the individual sites. So, you know, you might need another solution for that if you wanted to be selective about what gets replicated.
You mentioned application level versus infrastructure level. I guess there's an easy hybrid, which is if you don't transfer the file, but you're using shared storage like S3, the metadata that refers to the content URL, which is internet addressable, would just work anyway.
Yeah, we've had some conversations around that. I think you still have to deal with the hanging URLs. So the URL might not be valid for a certain period of time. Whereas at the application level, what happens is when you push the content, when you push the metadata over, you really don't populate the content URL until the content is comes.
I mean, let's not bother even using replication at the infrastructure level, but just still have a central store, so the metadata and the exploration and the collaboration can still happen, but the content transfer is slow because it never actually moves.
Gotcha.
Yeah, in that case, we would replicate the content property itself and
Yeah.
try and do that translation there. Anything else? You can ask each of us individually whenever you want as well. So thanks for coming.
Thanks.